Awesome. Hey guys, great to be here. We thought we'll do a quick presentation on how to think about interoperability stacks as they evolve. I think over the last years and months, we have seen an explosion of different interoperability technologies being offered to the market, and we've seen a lot of confusion of what they mean and how to think about them. So we thought we'd do a quick 5 to 10 minute overview of how to think about them. And we plan on continuing to produce a series of hopefully helpful videos over the next few weeks to give you more clarity and understanding how to think about Web3 and how to think about its scale going forward. So interoperability stack is messy, right? If you have been in the space, you've probably hearing all kinds of buzzwords, interoperability layers, chain abstraction, intents, omni-chain, so on and so forth. All of that is confusing. All of that is unfortunately doesn't help get to the next level of understanding of how to actually build in the space. So if you take a step back, though, the interoperability stack is very, very simple, and we wanted to simplify it and abstract all of that complexity away from you for you in two layers, right? So at the very core of interoperability is what we call as the general message passing, and I'll talk about that in just a second. And this is a very fundamental kind of core building block behind all the interoperability solutions. And on top of it, everything else you hear and see are essentially application layer protocols, right? And application layer protocols are there to simplify certain types of functions for you to interact and build applications that span multiple chains, and they leverage general message passing protocols in one way or another. And if you want to know more, I encourage you to kind of check out the recent post that we did. Otherwise, I'll talk about it for the next couple of minutes to give you a quick sense of what this all means. So what is general message passing? General message passing is essentially the primitive that's used to route messages across multiple chains, right? You have a smart contract or an asset on one blockchain. You want to interact with this asset or smart contract from another blockchain, and general message passing is the underlying primitive that allows you to do that. At the very core of it, these protocols are responsible for safety and liveness, right? So when we talk about safety, simply put, safety is a mechanism that allows you to validate that a transaction on a given chain is executed on a destination chain if and only if it actually took place on the source chain, right? So whenever you're talking about cross-chain, you'd have source chain and destination if you abstract everything away, and you want to make sure that the destination executes transactions from the source if and only if they actually included in the consensus mechanisms and finalized by the consensus mechanisms. So this is safety, very critical, very hard to work and to get it right, and it's sort of fundamental, right? If you don't achieve full safety, what happens is that the destination chain, because it's not aware of the source chain, could actually end up with an incorrect state. That will be very hard to deal with those types of problems, very hard to revert, very hard to deal at the application layer as well. And then on top of it, you also have liveness, right? Liveness are things like basic, they ensure things like actual time for delivery of your messages, right? So you want to make sure that if the message actually occurs on the source, then eventually it gets executed and included at the final destination. You want to make sure that process is as seamless as possible, as smooth as possible, doesn't introduce any extra gas complexities for the user that they have to interact with multiple gas tokens or pay gas across multiple chains. And you want to get the whole process to be as fast as possible, right? So you don't want to have to wait for hours to do that. And so liveness of all of this execution ensures that the transactions end to end satisfy a very smooth developer experience. So you need the general message passing protocols for settlement, for application composability, where contracts actually call one another, and various application layer protocols that we'll talk about in the next few slides. And safety of these protocols is where most of the protocols differ, right? Many different solutions exist out there, everything from very centralized solutions and multi-sigs to fully decentralized protocols that rely on open, consensus and open stacks. So this is a general message passing. So on top of it, as I mentioned, there are application layer protocols that have been built that simplify actions, cross-chain actions even further for the user. So what are these application layer protocols? One simple example are cross-chain or interchain tokens, right? There are many names that they go under, but simply put, these primitives allow you to launch a token across multiple chains and manage it as if it was launched on a single chain. Right? So you hopefully get the same address, the same name, the same supply characteristics, and an ability to move these tokens back and forth across chains. Classically, we have seen a history of like wrapped assets being deployed, which was a kind of a Gen 0 version of these interchain tokens. Very poor UX, different naming, different complexities, different fungibility properties. The next generation of these cross-chain or interchain tokens are much more advanced. Like I said, they have beautiful characteristics that allow you to interact with this token as if it was issued on a single chain and managed by a single environment, even though it spans across multiple chains, and you can send it back and forth. Another application layer protocol is known by chain signatures. Right? So chain signatures, effectively what they do is they allow you to submit a transaction and have a system of usually multi-party computation or nodes that would sign a transaction that can subsequently be executed across multiple chains. Right. So, for instance, if you have a wallet that lives on, Arbitrum, Optimism, and Ethereum, you can sign a transaction from the single place, and subsequently this transaction will go and be executed across any of these destination chains. So it helps you in the sense that you can have a single wallet and you don't have to have gas tokens to pay on multiple chains. But on its own, the chain signatures without full kind of interoperability or bridging support don't really help you to unify liquidity or really compose applications. For that, you still need either kind of bridging protocols, interchain tokens, or other types of bridging technology and general message passing interoperability protocols. So that's another chain signatures application layer protocol. CrossChain Governance is another very, very popular application layer protocol that we see a lot of demand for. Essentially, what allows you to do is to manage your application that spans multiple chains as you were to manage an application instance on a single chain. Right. So, for example, you have a parameter upgrade in your application, like you changing a swap rate from one token to another, or you introducing some type of a blacklist to filter for malicious addresses in your application, or you just have a software upgrade to your smart contracts that you want to deploy. What you don't want to do is you don't have to repeat this process chain by chain. Right. Instead, what you can do is you can build this interchain governance logic within your application to send any type of contract upgrades across chains and synchronize your contracts very easily. Right. So what that eliminates is that you don't have to set up keys for different chains. You don't have to interact with different chains at all. All the governance can be done on one chain, executed efficiently, finalized efficiently, and then these updates can propagate to multiple other chains. So Uniswap is one example that leverages kind of a cross-chain governance frameworks to actually update the parameters of its smart contracts across multiple chains, so they don't have to manage these instances separately. So very popular use case. So Intents is another popular protocol that's gaining more and more traction. Simply put, first of all, intents don't have to be cross-chain, right? Or they don't have to be multi-chain. They do make sense on a single chain as well, but for this context, let's focus on kind of cross-chain intents. What they are is essentially on and off-chain promises of an action. right? An example of an action is something like a transaction that could be submitted by the user that says, I want to swap one asset for another across chain B with certain types of constraints, right? Let's say I want to do it for, I want to pay, 1 cent for it, and I want to do it in 1 second. And I put that um, as the simple call for this action, and allow anybody potentially to come in and help me execute this action subject to the constraints that I specified. Right? Anybody could come in. Those anybody are often called solvers in the system. So solvers would come in, execute these actions, get the reward or the payment that's specified in the transaction, and the user gets to execute their action potentially more efficiently than they would do if they were to wait on the underlying infrastructure um, or on-chain execution. So these intents for cross-chain work quite well for things like swaps, right? As an example, on the Axel network, intents are implemented to help quickly swap one asset for the other across multiple blockchains, and often actually the whole process can be executed in under 5 seconds. They are harder to reason about and generalize for other types of use cases if your action is more general than basic swap for one token to another, but you can still think about it, and there are projects in the space that are thinking about those use cases. But again, intents are an application layer protocol, so often under the hood they rely on settlement or proof propagation by protocols like general message passing in one shape, form, or the other. But they help to automate and simplify certain tasks above that. So queries is another example of an application layer protocol. Simply put, queries allow a contract on one chain to find a state of another contract on a different chain. Right. So think about it like this: if you're coding an application on one blockchain, maybe you want to build in a price mechanism that depends on the prices of assets of other chains, maybe states of NFT collectibles, or it simply wants to make sure that when a certain purchase happens, it doesn't violate sanctions or certain jurisdictions, but the information about those sanctions and jurisdictions could live on another blockchain in a whitelist or blacklist types of frameworks or address books. So you can query for that information, get the result, and then use that in your application. Similarly, you can use it to fetch balances of users' assets, right? And that's actually very helpful in applications like wallets, where you want to aggregate, let's say, a stable coin like USDC balance for the user across multiple chains. So you can query for the balance very easily and display a unified balance for the user using these types of protocols. So that's about it. If you simplify kind of interoperability stack, that's really what it all comes down to, right? There's a general message passing protocols that deliver messages from one blockchain to another. By themselves, these protocols should be as simple as possible, have as few options as possible, have scalability that allows them to go and expand across any different chain, no matter what semantics or smart contract languages of those chains are. There are instantiated by different what you call networks, right, or different solution providers that differ in security guarantees they provide. And application layer protocols that we just described above effectively automate very common developer actions using general message passing frameworks into simpler APIs, right? So the developer doesn't have to code directly using general message passing and specifying how the tokens move back and forth, how the tokens are created, burned, but all of those kind of complicated actions can be simplified in a very simple API or primitive, and then package that into application layer protocol. And we're seeing quite an explosion of these protocols over the last 6 months or so, which I think is very, very exciting and will move the whole industry to the next level. So that's it for now. I hope to do more of these short recordings over the next few weeks, and stay tuned for a continued discussion where we'll talk a little bit more at what you can do with these building blocks at the application layer and what types of application experiences you can hope to deliver to your users. Thanks, everybody. Talk soon.